All right, so section 8.3, we're going to talk about adding, subtracting, multiplying, and dividing radicals. So as you recall, maybe not, I don't know, when you add or subtract your radicals, they have to have the same radicand, meaning the same number underneath the radical sign, and they have to have the same index, which means they're all square roots or cube roots or fourth roots or whatever they are. So it's kind of like considering combining like terms, where you'd have to have x squared and an x squared in order to combine them. You can't combine x squared and x cubed, right? Okay, so before we approach this problem, what we need to do is to simplify all three of these radicals. So 72 is 36 times 2, we get 12 root 2. 20 is going to be 4 times 5, so we get 10 root 5. And then 98 is 49 times 2, so we get 7 root 2. So as you can see, the 12 root 2 and the 7 root 2, those can actually be combined together. The 10 root 5 kind of has to be left alone. So 12 minus 7, we get the 5 root 2, and then just minus the 10 root 5. And that's it. That's as far as you can go. All right, well, we're going to see this as well when we have these binomial-looking things to multiply together. You can just apply the FOIL principle, or you can think of it as distributing if you'd like. But then you're going to eventually, after you multiply that all out, combine like terms, right? So root 6 times root 6, that's going to give you 6. And then root 6 times negative 3, and then 8 times root 6, those are those two terms. And 8 times negative 3, we get the negative 24. Okay, so now these two can combine together to give us the 5 root 6. And then the 6 and the negative 24 combine to be negative 18. So there's your answer. Okay, moving on. Conjugates. Conjugates come in pairs. And when you look at the conjugates, the only difference between the two is one has a plus sign in between and the other has a minus sign. Otherwise, these two values are the same. So the interesting thing is when you multiply the conjugates together, it becomes a difference of two squares. So if we take this, for example, right here, 2 plus root 5 and 2 minus root 5, when you multiply this through, you can see how the negative root 10 and the positive root 10, those are going to drop out. Root 2 times root 2 is 2, and then root 5 times negative root 5 is negative 5. So if these drop out, we're just left with 2 minus 5, which is negative 3. So quickly, when you do this, you could just look at the root 2 and square it to get 2. Look at the root 5 and square it and get 5, and then just subtract the two numbers. You don't actually have to go through and multiply it all out. So why are conjugates important or interesting? Well, we use conjugates to rationalize the denominator. So anytime we have a denominator that has a radical that is added or subtracted to some number, when we rationalize it, we have to multiply the top and bottom by the conjugate of the denominator. So that means in this case, we're going to multiply the top and bottom by 4 minus 3 root 2. Now, this is going to be messy because in the numerator, we have to FOIL all that out. These are going to get multiplied together. So 2 times 4 is 8. We have the negative root 3. The 2 times the negative 3 root 2, and you get negative 6 root 2. Negative root 3 times 4 is negative 4 root 3. The negative root 3 times negative 3 root 2, that's a positive 3 root 6, because the 3 and the 2 get multiplied together. Now, in the denominator, if you wanted to, you could multiply this all out, or we can just think of it as the difference of squares. So 4 squared is 16, and we're going to subtract. And 3 root 2 times 3 root 2, well, that's 9 times 2, which is 18. So the only thing we can do here, since the numerator cannot be combined, nothing in here can be combined, we can subtract those and get our answer. And if you really, really, really wanted to, you could divide the negative 2 into all three of these and have a minus 3 root 6 over 2 if you wanted to. But this is totally fine to leave your answer like this. Okay, so there you go. That is section 8.3.